Hello student, we can start today is one more method by minimizing a DFA by table filling method. So this is the eighth lecture of our pre-video. In this we will discuss minimizing a DFA by table filling method. This is a one popular method. It can expect one question from this topic which is very important, right? As you have seen in the previous video, we have done one of the problem minimizing a DFA by partition method. Today we will see one more method is called table filling method to minimize the DFA. Before to that, so we will see there are two terminologies is very important. Need to understand what is that two terminologies before go to solving the problem. So what is the terminology distinguishes? So what do you mean by distinguishes? A pair of state, a pair of state, a pair of states P comma Q is said to be distinguishes if there is a string W such that either delta P comma W is belong to F and delta Q comma W is not belong to F, or delta P comma W is not belong to F and delta of Q comma W is belong to F, then P comma Q are distinguishes states. Then similarly, another terminology is indistinguishable. A pair of states P comma Q is said to be indistinguishable if there is a string W such that either delta P comma W is belong to F and delta of Q comma W is belong to F. That means that the pair of state, one of the state is belong to F, in another state also belong to same final state, or then P comma W is belong to Q minus F, or and delta of Q comma W is belong to Q minus F, then P comma Q are indistinguishable state. Now now students, you understand the distinguishable indistinguishable state. When you say it is a distinguishable states, so whenever the one of the state is belong to final state, other states is belong to non-final state, then you can say to be distinguishable state. Suppose one of the state and both the states is belong to the same group, then it is a indistinguishable states. So when I understand these two terminology, it is easy for to solving the problem by using a table filling method. Before to move to the problem, let us see two rules. Two rules are very important. The first rule is basis. For each P is a state in Q minus F and Q in F, mark P comma Q. That means one of the state in non-final state, another state in final state, then you have to mark PQ in the table. That is directly you can mark it. So second rule is induction steps. For any pair, suppose P comma Q, if there is some input A such that delta P comma A and delta Q comma A is marked, then mark P comma Q. Suppose you have to check this transition, you have to check this transition indirectly. Is it already marked by basis rule? Then you have to mark P comma Q in the table. So these two are, I think you understand the basis rule. It is very clear it. One is in Q, one is in one is in F and other one is in non-final state. Then you can directly mark it. But in the second step, you still have to check it. Any pair of the states are still, it is a distinguishable, then you have to check them in through the transition by using a induction step. These two steps will be understood clearly while solving the problems. Okay, let us move directly to the problem. Okay, So this step 3 is repeat step 2 until no more pair can be marked. Repeat step 2 until no more pair can be marked. So this is possible. Okay, so this step will be repeating again and again until no more can be marked. I'll take the minimize the following DFA. They have given the transition table. Here it is. I have taken this example. There are 5 states are there. So either may give transition diagram or may transition table. So I'll go to the table. Solution. Before take up to this, I take this is a data. How to make that is a pair of state. How to make a pair of state is here. How to start with a. I'll pair with A, C, then D, then E. How to make like that? Okay, AB, AC, AD, AE. Right? So then so you have to start with B, BC, BD, then BE. So second BC, BD, BE, right? So that is one case is over. So still you can make a pair CE, CD, CE. So that is possible, right? So one more pair you can make it. What is that? DE. So DE. So pair is ready now. We have made all the pair. So correspondingly you have to prepare the table. How to prepare that table? Look at this table. Is very easy. Now you can make this. First you have to take horizontally as a vertically B, C, D, E. Don't take, right? Don't take A. So in horizontally you take start with A till D. So now I'll follow the rule. What is the rule here, right? Look at this. Any pair is distinguishable by basis rule. Which is the final state here? Which is the final state? Final state is C. Right? So what are the state? What are the state is pair with E? One is A comma E, B comma E, C comma E and D comma E. You can directly mark in table. Yes. So AE is marked by X0. You have done it, right? Okay. Next. B is marked by X0. So then you have done this. Right. Next. So C is marked by X0. Yes, you done. Right. Then D is marked by X0. Isn't it? So right. So this is X0 directly can mark this. This is gone. Right. So this pair of state is over. We apply the basis rule. You apply the basis rule. Right. What are the remaining pair of state? AB, AC, AD, BC, BD, CD. This pair of state can take into the step 2, that is the induction step. Then how to find out the transition. So for A on A, so A on this pair of state, A on A, so that is A on A is B and B on A, B, right? So these two are, look at this table, delta of A comma A, it is A on A, B and B on A, B. A on A, B, B on A, B, right? Similarly, can find the other transition on B. So, A on B will get A on B, C, right? B on B will get D. So, similarly, so further other pair of state is AC. Find out the transition for that. A on A, AC on A will get BB, AC on B will get CC. Other pair is AD, A on AD on A, BB, AD on B, CE. So other pair is BC, that is A on that BB, BC on B is DC. So then BD is on A, BB, BD on B, DE, right? CD on A, BB, CD on B, CE. So we have completed all the transition, then you have to take the call now. How to make that call? Look at this. I'll explain this. First I have to check resulting states. CD is marked by X naught. No, it is not marked by X naught. Then, so CCBB is not possible. Then CE is marked by X naught, then you have to mark AD. So you have to mark AD by AD by X2, X1, sorry, AD by X1, right? Then, so this is D is by X1, you have to mark BD. Then C is by X0, then you have to mark by CD is marked by X1. So now tell me which is AD is marked by X1, then BD is marked by X1, then CD is by X1. So there is no more state now. Again, so still three more pair of states are there. You have to repeat step 2. You have to repeat step 2. So what are that step 2? Okay, repeat step 2 for remaining pair of state. I'll take this step 2. Okay, I'll take AB, AC, BC. Now CD is marked by this case. CD is marked by X1, CD is marked by X1, then I have to mark AB, right? Next, CCBB is not possible. Then let us move to the last pair of state. CD is marked by or DC is marked by X1, then I have to mark BC. Okay, you have to mark BC. Then I'll show you that by BAD, AC is marked by, sorry, AB is marked by X2, then BC is marked by S2. What is the remaining pair of state? So it's not possible. Repeat a step 2 for remaining pair of state. There is only one pair of state. Again, there is not possible to mark in a table because BB, CC are not distinguishable. Then AC becomes merge, single state, right? This is becomes single state, right? So no more pair of states can be marked, then stop the process. Therefore, state of the reduced DFA is AC, B, D, E, right? Earlier there are 5 states, now reduced to 4 state. Okay, there is no more pair of state can be marked. Then stop that process. Then write down the state of the reduced DFA. Okay, reduced DFA. So now how you have to therefore the state of the reduced DFA is AC. So for that you have to write a DFA. For that you have to write a DFA. I have written this DFA. Okay, look at this diagram. This is a DFA for you people. Look at the transition table and write down the DFA. And these are the final state. Okay, then and M is as describe that. M have to describe. M is equal to Q sigma delta Q naught F. Q is nothing but AC, B, D, X sigma is AB, Q naught and A. So now, so this is a transition table. This will be the initial state. So this is with this we have discussed the minimization of DFA, and this is one more problems we will be discussed in the classroom. This is very important and have to solve in the blackboard. So thank you guys. With this, entire module of 8 is completed. Thank you guys.